Okay, now that you know how to identify the parts of a reaction and balance a reaction, it's time to learn about the different types of reactions. So there's a total of 6 different types of reactions. The first one is called a synthesis reaction. The word synthesis or synthesize means to make. So what goes on in this reaction is you take 2 smaller components, okay? It could be like in the sample down at the bottom. It could be 2 elements and then you combine them to make a compound, or it could be 2 compounds and you combine them to make a more complicated compound. But regardless, you have 2 things that are separate and then they combine together in a synthesis reaction. So a very simplified way of saying this is you have substance A plus substance B, which are separate, make substance AB that are now combined together. Okay, these simplifications might come in handy for assignments later, so you might want to write those down. So, this is actually a fairly interesting synthesis reaction. In the email that I sent you with the link to this video, there's also the link for this burning of magnesium video. The next kind of reaction is a decomposition reaction. Okay, so this is the opposite of synthesis. Decomp means to break down. So here you take something that is more complex, okay, so a compound, and you split it into 2 elements, like our sample down here, or you take a larger compound and split it into an element in a compound, okay, but you're going to take something more complex and break it into smaller parts. So the reaction, the simplified reaction for that would be you start with AB and make separate A plus B. Okay? So, and then here's, this link is also in your email, but to a decomposition reaction. A lot of times when you get a gas given off, it's potentially a decomposition reaction. So the third kind of reaction is called a combustion reaction. By definition, a combustion reaction is something that burns in the presence of oxygen. Okay? Now, the vast majority of combustion reactions involve hydrocarbons. So, this carbon and hydrogen compound, like fuel. Gasoline in a car goes through a combustion reaction. A lot of energy is given off, and then our cars use that energy to continue driving. Okay, so the hydrocarbon basic reaction would be kind of like CXHY, because you can have a very different number of possibilities for how many carbons and hydrogens, plus oxygen, makes CO2 and water. If it's a hydrocarbon reaction, you're always going to make carbon dioxide and water. Okay. Then, in the second half of the types of reactions in the unit, there are single replacement reactions. Okay, so what happens is typically you're going to start with something in its elemental form and then a compound, and that element is going to replace, or actually your book or your content actually calls this displacement reaction, single displacement. And I'm running out of room. Okay. Replacement, displacement, they both kind of mean the same thing. If you displace something, you kind of kick it out. If you replace something, you kick it out and take its place. Okay. So what's happening is the zinc is going in and knocking out the carbon. So now the zinc is attached to the sulfate and copper is on its own. The generic way of writing this equation would be A plus BC yields B plus AC. Okay. And then number 5 is a double replacement reaction, or the way your book says it, double displacement. So in this case, you have two compounds reacting. Okay, so like down here we have silver nitrate and sodium chloride. And then what's going to happen is the negative, you can think of it as either the positive ion switch or the negative ion switch. But essentially what happened is silver and sodium switch spots. Okay, because now silver is attached to chlorine and sodium is attached to the NaNO3. Okay, so the generic version of this looks like AB plus CD becomes CB plus AD. Okay, the compounds in the front switched. Okay, so of the 5 that we've talked about so far, see if you can classify, so look at the reactants and products and see if you can match what type of reaction is happening here. So pause the video, try it yourself, and then start the video back up. So, first one, we have a hydrocarbon, carbon and hydrogen, reacting with oxygen to make carbon dioxide and water. So this is a combustion reaction because we have it reacting with oxygen and making carbon dioxide and water. All right. Next one, we have hydrochloric acid, sodium hydroxide, making water and sodium chloride. I'm going to rewrite the water because this is probably going to make it a little bit more visible as HOH. And now I think you'll be able to see that hydrogen and sodium switch spots. So this is a double displacement. Alright, and then down here we go from one item, so KNO3, to KNO2 and oxygen. So this compound gave up an oxygen in order to become simpler. Okay, so we're going from one thing to two things, so AB to A plus B. This is decomposition. I might have just spelled that wrong. Alright, so try these 3. Pause it, try it on your own, and then come back. Alright, so first one, we have silver and sulfur making silver sulfide. So we go from two things to one thing. Okay, so A plus B to AB. This is going to be synthesis. And then we have MgCO3 becoming MgO and CO2. So the magnesium compound lost carbon and a couple of oxygens. Okay, so it went from being more complicated to less complicated. Or we have one item becoming 2. So this would be a decomposition reaction. Alright, and then here we have element in a compound making another element in a compound. And you can see that what happened is the chlorine went in here and kicked out bromine. Okay, so since it's one thing being kicked out, that's single displacement. Okay. Alright, the last kind of reactions is really, it's more a different way of talking about some of the other reactions we've already seen. So oxidation and reduction reactions. They're a group combined together. And they get their name from the fact that these were first kind of discovered and talked about in regards to oxygen. So sometimes when you have a reaction with oxygen, we call them an oxidation reaction. That's where the name comes from. So, what's the name comes from the fact that in this reaction, and we've seen this one before, this is a synthesis reaction, so this is just another name for, like, this groups together some other reactions, because combustion reactions can also be oxidation reactions, okay? But what's going on is because the magnesium picks up an oxygen, it was oxidized, okay? So if something gains an oxygen, an element gains oxygens, it's going to be called oxidized. The opposite of that, a reduction reaction, is if the element loses oxygen, then that compound, or if a compound loses oxygen, it was reduced. So in this case, here we have H2O, and then it's just separate O2 and H2. So hydrogen was reduced. All right. So to practice that is determine in these reactions which element is either oxidized or reduced. Okay, so pause the video, see if you can do it, especially that last one's a little tricky. Okay, but pause it, come back and see if you got it right. So for the first one, we have aluminum on its own and oxygen separate, and then we have aluminum attached to oxygen. So aluminum was oxidized. It gained oxygens. Oxidized. Okay. Next one, we have copper attached to oxygen, and then we have, which makes copper on its own. So what's going on here is we have copper being reduced because it lost oxygen. Okay, and I mean, you can also see here that you have a synthesis reaction and a decomposition reaction. So oxidation really isn't its own type of reaction, it's just a way of looking at oxygen-based reactions. So the next one. This one's tricky because you actually have both things going on. So if you look at your iron goes from being attached to oxygen to not having oxygen. So iron is reduced. But if you look at your carbon, carbon starts with 1 oxygen and ends with 2, which means carbon gained an oxygen. So carbon is oxidized. So sometimes you can have both things happening in the exact same reaction. Okay? So I hope this helps make sense. If you have questions, please contact me.